Okay, so let me say one big thing you're supposed to have picked up from this, and how in calculus it's totally necessary to, if you're doing a free response, they won't just want you to tell them what's the vertical asymptote is x equals 3. If they say explain why, or you want to always show your work anyway, we'll get over all of that. Not on today, we have shorter time together, but I'll explain more ongoing how you want to answer the test, what you want to write on the test, and blah, blah, blah. Anyway, to justify your answer that you have a vertical asymptote, you use limits, okay? So a lot of times you'll feel like they want you to write words, and sometimes you will write words, but lots of times you'll use just a very classic notation, okay? So I'm going to do it with my hands, but you won't be able to see the video, and then we'll draw it, okay? Or I'll write what you should say about vertical and horizontal asymptotes, all right? And you sometimes have to deal with a slant asymptote, but I've never seen them out and out ask that. But you know, if the top's one higher than the bottom, it's in behavior model slant on. It's also probably yes. All right. So anyway, here's the difference in the two asymptotes. Vertical asymptote, you're going toward a number and you get pulled off to infinity. A horizontal asymptote, you're going off to infinity and you get pulled towards a number. See the difference? If you, or they can announce this to you. They can say the limit as x approaches 3 from the right is infinity. You would assume that they're trying to tell you there's a vertical asymptote there. You're coming toward 3, you got pulled off to infinity. Okay? One thing you're not going to have to decide between is, suppose I've told you this before, if you got infinity and D and E, if your graph is going like this, they're not even going to give you that, okay? I mean, they're not going to give you both of those in a multiple choice. Because you could answer either one. The limit doesn't exist if they both go off to infinity. But they're both also, the two-sided limit, they're both going off to infinity. If you're doing a free response, it's acceptable to either say D and E or infinity, but you'll find as the year goes on, it's a little more clear to say, if you can, which way it's going, because it helps you draw and it helps us talk about it, okay? This, we definitely would have to do a clear D and E, right? Because it couldn't call that infinity or negative infinity. That would be a full out D and E. But on multiple choice answers here, they would never ask you like A, infinity, and B, D and E. They might say infinity, negative infinity, something. They're not going to make you pick between those two, okay? All right, so, so this is like how you'll say you have a vertical asymptote. A vertical asymptote occurs if you take the limit of your function as x approaches c, and let's say from the right, and you get pulled off to positive and negative infinity. I just said and, I meant or. As x approaches c from the left. So that's just the clearest way. I mean, you won't do it that vague. You'll say I approached 3 from the right and it went to infinity, and 3 from the left and it went to infinity. That's when you converse with me or your, you know, your Cal 3 teacher next year that you have a vertical asymptote, and that might be how I communicate it to you. So you're coming into a number, you get pulled off to infinity, okay? And y'all see that means plus or minus, okay, which we really have always said when we've square rated. I'm not square rating right now, so it's kind of a silly comparison. All right, horizontal is I go off to infinity and go toward a number. So here I go toward a number, get pulled to infinity. Horizontal, I go to infinity, I get pulled toward a number. Super common sense. I always teach, I strive to make you understand it. You have to memorize a lot less if you understand it, okay? So hopefully you're really getting what I'm saying. Horizontal asymptote can only occur if you take the limit of a function as x approaches infinity, positive or negative infinity, and you get pulled towards some number, to some constant. Tons of graphs don't have either one of these. Some have one or both. You just kind of got to look around and see, okay? You definitely can have different horizontal asymptotes going in different directions. A couple of classic examples that I'll give you before I take specific ones. A lot of times if it's square root or absolute value, I think I had one in the video that maybe did something like this, where it leveled off this way and it leveled off that way, but it had some sort of absolute value or square root in there. And so sometimes I've seen something have two horizontal asymptotes. Sometimes you'll have just one behavior that acts one way in one direction and another way in the other direction. How I would talk about this is I could say the limit as x approaches negative infinity is 0, but the limit as x approaches positive infinity is infinity. That's still a horizontal asymptote if at any time you get pulled toward a number. Okay? Alright, now I think I gave you the answers of worksheets 1 and worksheets 2 over a period of time. Is that correct? I mean, does some of you know the answers to? Oh, I think I sort of quit on 2, somewhere around 7 and 8. Let's look at worksheet 2. Number 4 is -1. Number 5 is 2. Number 6 is 0. Number 7 is 4. Number 8 is 2. And 9 and 10, 11 and 12, I think I just sort of left that for you to type into your calculator. If you really tried these, you should have seen an interesting, maybe sketched a graph, some of you on your worksheet. You saw this interesting, like from the graph, getting squeezed between two things in the plane in question. Any questions on that? Anybody want to volunteer what they thought the answer to 9 was? 0. Okay, so those two graphs were going into 0, and so this weird x cosine 50 pi over x is also. Number 10, 1, 11, 12, 3. So I need to tell you what it is. The good news is I've never seen them ask you to do the squeeze or call the sandwich theorem yourself. Okay, if you watch the video, I drove some really bad Oreos and peanut butter jelly sandwiches. But it's good to understand there are occasional times that as a mathematician, I just can't, it's hard sometimes to handle a function algebraically when you suspect a limit that does exist, and if you can think of two functions to squeeze it between, you can make it work. The hard thing, of course, is thinking of two functions to squeeze it between, which you haven't had to do yourself. But if you look at these, what these people thought up, it's just like what I've known that is between these two. So I just kind of skate over that. If you want to make a note yourself, you're not going to be asked to do the squeeze or something theorem, but I surely need to say it for many of you that will go all the way through calculus and differential equations in your major. Okay, on worksheet 3, let me just, do I have given the answers on worksheet 3 yet? Yeah. Oh, I did a lot of it, and I gave a lot of answers. Okay, so hopefully the ones that I skipped, you tried on your own. When I do homework this way, hopefully you had your worksheet out and you were working as I was teaching, or some of you may have tried it and looked at the video. There'll be times I don't have time to go over all the homework in class, but I know there's lots of questions. And so a lot of times you'll get a video of me working the problems, and you can fast forward to the one that you need, and you don't have to watch the whole thing. But that way at least you're getting your questions answered at 1 o'clock in the morning if that's when you want to look at it. You're welcome to meet with me also. All right, so questions. Morgan.
For number 9, what does the x cubed do to the graph?
It's very interesting. Let's look at that one. All right, so this is my favorite slide.
It has to be DNA.
My favorite. Okay. If I had a pig, that's what it would be. So I have the limit of x cubed, absolute value of x minus 2, over x minus 2, as x approaches 2 from the right. Is it just say 2 from the right? And then, I told you to omit 10. I didn't really, wait. Yeah, so just 9. I thought they were the same at first. 9, they only are saying 2 from the right, aren't they?
Yeah.
Okay. But I'm going to graph the whole thing. I'm going to say as x approaches 2 from the right. Okay, now I never leave absolute value on there. I always rewrite it, but your Algebra 1 teacher started you, and your Algebra 2 teacher, you've not had a teacher just left absolute value there. They started out, it could be this or it could be this. But now we're big enough to know, we're old enough to know, we're mature enough to know that we can sometimes just make a decision. If I'm to the right of 2, do I even need those bars on here? Be careful. There's going to be a big difference if you have 2 minus x in the bars than if you have x minus 2 in the absolute value bars. You know, like 2 minus 3 is going to be a negative, in which case I need to totally change it. Okay? So if you have a positive inside of absolute value bars, the bars are doing absolutely nothing and you can drop them. If you have any kind of negative expression inside the bars, you can drop the bars as long as you totally change all the signs. Take its total opposite. Alright, if I'm coming at 2 from the right, I don't even need that. So I have x cubed times, this is very great, I love this graph, over x minus 2. Hopefully y'all know from your pre-cal and your algebra that you now have a hole in the graph at 2. Okay? And so this does not exist at 2, but I know what x cubed looks like. Okay? And it picks up at 2,8 and continues on. Don't ever draw me a graph to grade without units marked off. I don't know if I'm gonna get up to 8 here, but pretend like I just did. All right, so you don't want this part on here. And so it was just that part of the x cubed function you would need to show, and hopefully a prettier open circle than mine. And so it's just closing in on 8 as I come from the right. But what's interesting, that must be Mr. Nunez. How do you say his name?
Nunez.
Nunez. I love his laugh. Yeah. It is one of the, it reminds me of an administrator I used to have that had that hearty laugh. Alright, as x approaches 2 from the left, the absolute value of x minus 2, if I come from the left of 2, like 1.9 minus 2, if I'm coming really close from the left, this is a negative value. I gotta drop the bars, but I've got to take its total opposite. Let me prove to you that that's okay. Let's see, Emma, give me a number less than 2. 1. 1 minus 2 is negative 1. Absolute value is 1. If we put Emma's in here, I think you said 1.
Yeah.
Don't I get the same answer either place?
Yeah.
If I picked 0, it's fascinating. If I pick 0, I get 2. If I pick 0, I get 2. Okay? Alright, so on this one, we're going to just do it more than is needed here, but it's interesting to look at. Because you're supposed to be able to handle all this piecewise stuff anyway. Alright, now I'm going to take the limit as x approaches 2 from the left. I'm going to factor a negative out. Or maybe some of y'all realize, hopefully you realize I move faster during the year. These are complete opposites of each other, aren't they? Like I can just freely cancel out x plus 3, 3 plus x. Those are the same thing. You're also free to cancel out x minus 3 with 3 minus x, but those would be opposite numbers, won't they? What's 5 minus 3 is 2. 3 minus 5 is negative 2. You can cancel them out, but you get negative 1. Okay? So one way or another, you know, you may have been the person that knew if you cancel those, you have a negative x cubed. And I'm only going up to 2 from the left. And so I'm graphing negative x cubed. I'm sorry, I lost my train of thought. Okay, negative x cubed looks like this. Negative x cubed looks like this. Are y'all okay with that? I take for granted you know a lot of functions, okay? And so I'm graphing this only until I get to 2. Supposing this is 2 right here. And so it's my piecewise function that comes from this way. At 2, it jumps up here and continues up. So the limit does not exist at 2. It does exist everywhere else. Our word for today that we're going to get into in a minute, this is discontinuous at 2. Okay, we're going to talk about continuity. So anyway, that's what the whole entire graph looks like. And I'm getting a lot of good questions about, when do I use my calculator? What if my calculator gives me the wrong picture? Can you see, you can't see, I use my calculator a lot, but I also use a lot of knowledge about functions, a big awareness of domain, behavior, things like that, okay? So the limit from the left would be negative 8, so I didn't draw that on the scale, which is really that should go all the way down to -8. It did on my paper. Okay, but the answer to 9 after all of that explanation was 8. Caroline?
Emma and I were working number 19, and
Okay.
when I graphed it on my calculator, I got that the left side, it like dropped off to -infinity, -infinity, but then we put in some values and got positive infinity.
Yeah, it should go, because it's an x squared, so it should go to positive infinity, right? So let's see. I'm sorry, I'm not letting you in on what's going on in my head. It says 3x cubed on the top and x on the bottom, so its end behavior should be 3x squared.
I don't think it is.
So let's check.
Take like the highest of these, divide them, and then you just get 3x.
Right.
And then you just use that.
Caroline, you gonna let me know? Are you typing it in, or you've already done it, and you're like, I don't think it is?
I have it.
Okay.
Yeah, I have it on my, yeah.
Yeah, it starts like at -infinity on the left side.
Well, that's not okay. Let me see what's happening. All right.
I didn't know it, and like, I just did like what I needed.
Probably gonna bring, keep forgetting I have a touch screen. 3x cubed minus x. Oh, I always do that. Minus x plus 1 thing. Divided by x plus 3.
But I don't know what it looks like.
Already in army.
So hopefully we have where we don't.
Okay, I put in -1,000, like negative infinity, and it's way up at 3 million. Okay, wait, I got a great answer to your question. But we did it last, I have a great answer, but you've seen some of this before, it's just being reminded of the end behavior model. The end behavior model, is y equals x squared. Life does not exist in a -10 to 10 viewing window, okay? And so I know that it's gotta do this. But like some of my pre-cal problems that Mr. Hill and I would give, is you just might not be seeing where the thing is, but it's there. And who's your best friend? Who can you ask? Table. So I'm gonna go to table and go, Caroline, we know there's something back here that's great. You're assuming it's going down, but you know it can't
Yeah.
be, so it's a good question. So I can go to table and go, well, where are you? If I put in -4, for instance, that's why I don't see it, it's up at 187. Okay, so I knew that my end behavior model had to be some form of a 3x squared. In a loose form, it's gotta follow that pattern off. And so I know there's some more out there. Now I can change my window and go up to like I don't know, like 150, and I probably will see it. Still, I may still not see it.
Go to Zoom a bit.
Okay, hang on, we don't do, usually don't do that, I'll talk about raw.
Let's go.
I'm going to go to 200, because in table it said 160 something, I think. There we go. Okay, so table told me it was up in the 160s, so I just changed my table. Do you see how it's like as I zoom out and zoom out and zoom out? Okay, I don't zoom out and zoom out and zoom in and zoom in. The reason, I may have mentioned that in here before, zoom fit can be very scary to this level of calculus, because it can go and fit you somewhere that you don't, you want to be in total 100% control. It's very rare for me to zoom in and zoom out. It's a whole lot easier for me to change my window where I want to be. I've zoomed in before or watched a student and it's like on your map when you're trying to do something on your phone and all of a sudden you're, down close to Battery Park when you can't even, you've got to start over again. You didn't even want to be there. You wanted to be in Midtown. At least that happens to me. I don't know if y'all know what I mean. Like you're like, wait, where did everything go? Okay. So I strongly suggest being in total control of your calculator. If you do things like hit zoom fit, there's also, let me tell you, you're going to be finding maxes and mins. There's a max and min key on your calculator that I've never actually used, and I don't recommend you use it, because all it's going to do is find the max that you see in your little stupid -10 to 10 viewing window. What if we know by calculus there's one out at 42? You've gotta be in total control, okay? You see how Zoom Fit might not even give you the whole picture. It's really cool up until this point, and I'm not saying you're not gonna use it, that's just, use it with caution, and if here it would have been great, I don't even know, somebody over here said Zoom Fit. Here I maybe would have taken you to it, I just control it myself. But I love the thought that you knew that it had to go off to positive infinity. And at that point, you're just fighting with your calculator to show you something you already know, okay? Girls, life does not exist in a negative viewing window. I kind of dislike the fact that we do that for so many years in upper school and middle school. Like, we should have you graphing, or maybe we do, and then everybody goes back. This kind of it's a standard viewing window. I don't know, even though I know, okay? Not for us. If you do want to go back to that standard viewing window, then you can hit Zoom 6. That is one of the times that I use that key. All right, great question. Other questions on the worksheets? So this last page of worksheet 3 was, you were going to infinity and negative infinity, and I guess you clued in by the questions. They were showing you how you're expected to find horizontal asymptotes if there are some. Okay? Let's see if there's anything else I want to do. There's a good outfit value one on 22. I may have done that one for you. I don't remember. It's a blur. So let's do 28. 28. We have cute little chickens. So we have f of x is equal to secant x. Two little chickens always reminds me of this. When you loved for me to be your little sister, can you imagine how much you could pick on me and boss me around? That's what happened. My big sister, she always just like bossed me around and got me in trouble, and I was real quiet and sweet. And she wasn't. We're best friends now. She's awesome. But she was 2 years older. She's still 2 years older. Anyway, we were little bitty girls, like 4 and 6 years old. Our parents for Easter gave us these 2 cute little chickens, which is a bad idea, don't do that. But anyway, they gave us 2 little chickens, and we had them in a little cage or something in our room, and I was so excited. And we went to bed a few nights. We shared a room. And yeah, probably needed to be outside. I don't know. Anyway. We woke up one day and our parents were like, Mom was sitting on the bed and she's like, I'm so sorry to tell y'all. She just like looked at both of us in our twin beds and she said, one of the chickens died last night. My sister looked straight at me and said, I am so sorry your chicken died. I burst into tears because that's what our relationship was. It didn't even occur to me that it could have been, I mean, it was years later that I was like, wait a minute. How did you know that was, they look exactly alike. How smart she is. She's just so witty. I would have never thought of that. So then she had a chicken and I didn't. But it maybe it was my chicken. Okay, so okay. So, anyway. Did I do this one on the video? No. Okay. Cosine goes like this, and you should be like well versed in that. If you're not, go ahead and start thinking about it because you need to get faster at it. Secant goes like this. And the only places they really share are at these amplitude, well, secant doesn't really have an amplitude, at these places where it's 1 and -1. And so we have these asymptotes. Asymptotes, of course, are going to occur wherever cosine is 0, which happens every pi over 2 radians, pi over 2, 3 pi over 2, and so on. And so you could just say x cannot equal pi over 2k, and you do need to define what k is this year, where k is any integer, which is kind of a pain to write out. In fact, do I want, yeah. Wait, 1 pi over, oh, where k is any what? I don't want it to be any integer. I want it to be any, where's cosine 0? At 1 pi over 2, when's it 0 again? At 3 pi over 2. So I want k to be any odd integer. So So that aggravating, you know, you felt like last year, in fact, I love some of my students, and they drop it off where I didn't make you write where K is in the integer all the time. I don't know what you did in Mr. Hill's class, but now you all of a sudden see that it's important to tell someone what K is. You don't have to use K, you can use N, you can use R, pick a letter. Most people use K. But some people don't. Is that okay with everybody? Okay. So now let's move on for a few minutes, and please, if you're one of the ones that just ease out quietly, because what I'll do the last 15 minutes is super important. Okay, so I did a bunch of trig limits in the video, and the limit of sine of x over x as x approaches 0 is what? 1. Okay, good. All right, and I took you through the squeeze theorem to show you that, okay? And this is not something you need to write down, you can just watch. If I am in radians, that is true. You could just watch this. This is just the moment in time that I'm going to tell you why calculus doesn't work in degrees, okay? All right, so, boy, that sounds really scary. Okay, so sine x over x, I don't even know what mode I'm in right now, but I'm about to find out. So if I graph it, I must be in degrees, right? Okay, so you can do this and it'll stop it.
Wait, how do you?
Oh, no, that's in radians, we're good. I was saying because it was so little, but.
Wait, how do you stop it?
Hit the on button.
Oh my gosh, thank you. I'm always sitting there and I
too.
grab something
Yeah,
and I realize it's wrong and I'm sitting there
Yeah.
for like 20 seconds.
Just hit that.
Oh my.
Okay,
Wow.
girls, it's getting closer and closer to 1, but there's a hole in the graph there. If I go to table, which by the way, I heard that when you watch the video and it had sine x over x in it, and then you think back to the test, you think, well, that's not fair. You didn't. The thing on the test didn't have anything to do with the limit as x approaches 0. It was more what happens as x gets bigger and bigger. It does have a horizontal asymptote at 0. Okay, so I mean, it was all like, that was a trick question. Now I'm moving it into calculus. I showed you with the squeeze theorem how that equaled 1. If I go to table and I fill in 0, it's undefined. If I put in 0.001, I get 1, or really probably something really close to it. Okay? And it just gets closer and closer, infinitely closer to 1. So memorize that, know it, and you also will have L'Hopital's rule later, which Anna already knows, and some of you others might. If you know at all what I just said, L'Hopital's rule, you're welcome to use it. I don't teach it until like February. I'll get back to it. Okay. So, years and years ago, one of the smartest people that I've ever taught is Shay Aluko, who went to WashU and then went to Stanford Medical School, and now he's doing research somewhere or something. I don't know, I need to track him down. But Shay he was really maybe not one of the smartest people, because I teach UC every year, but he was one of the most questioning people, which I love. He would always, I'd go, you gotta do your calculus and radians, and he'd be at my desk in the afternoon. Why? I don't even know why. So Shane and I would sit down with theorems that I really didn't, nobody had ever shown me things, and I hadn't had to know it. And I'll show you a few others that we'd sit in the afternoon and just write our own proofs, which is so much fun. But anyway, Shay and I were like, okay, let's just take it at the beginning. His question to me was, how does the calculus problem even know what mode you're in while you're writing it on your paper? So we started on our paper and we started writing. And we got to this point and we thought, we're gonna go in degrees, and something made one of us, we were probably just talking over each other and talking really rapidly. But when we checked it in degrees, the limit of sine x over x isn't 1. And so all that stuff that you would learn about trig limits is gonna fall apart in a hurry, okay? It is a constant, but it's 0.0175. If you're in degrees, it heads to 0.0175, which his brain wouldn't stop there. It gets closer and closer, by the way, to a certain number, which was fascinating once we just sat there going, okay, that's really cool. I can prove with the squeeze theorem why the radian one goes to 1, but I'm thinking, we're both like, wait, what's happening? what is that number, okay? Does anybody know what that is? It finally dawned on us, which is super cool. Any ideas? It's the conversion from radians to degrees. Is that cool or what? So if you want to spend all your time in degrees and convert it to radians, you go for it, okay? But I'm not going to. It's a big, big deal. The derivative of sine, I told you the other day, if you didn't already know it, is cosine. I'll prove it to you later. If you're in degrees, it's not. It's 0.0175 cosine. And some things get worse, like the derivative of tangent secant squared, so you have to square that coefficient. I'd work in radians if I were you. I've never seen anybody do it in degrees. Okay? All right, so now.
Oh, yeah, have fun.
Oh, and by the way, I'm reworking the syllabus a bit, so make sure you keep checking assignments. All right, big deal, continuity and the intermediate value theorem. All right, I'll find a better color, but I'll go in and write this. Continuity, if I have to write it fast.
T1.
I shouldn't have like slowed down because all of a sudden I couldn't do it. All right, how do you know if something's continuous or not? And almost all of the theorems that we learned in here, and by the way, I like geometry, I'm studying geometry, but I've taught many geometry, so I need to unname it. I just had never taught it, and that's why I came to Marymount, which case I liked it a lot better than I thought I would, but it's my least favorite of the math. And I don't remember all those theorems. You notice some of us that don't teach geometry all the time, I can speak, so me and myself, if I can speak for her, if you come into math center with a geometry question, we gotta get out a book and go, what's that theorem? Whereas all this calculus on the tip of our tongues, okay? So I said all of that. Don't let the word theorem scare you. It just means like something I gotta teach you. It's not gonna be that you're gonna have to, you may have to prove something to me in here, but it's more of a fluid. You'll never do it too concrete, okay? But you're gonna have a lot of things that aren't true if the graph's not continuous. And you can go, it's not continuous. No, I'm not even doing it, which is great if you don't have to do it, okay? Like the intermediate value theorem, the mean value theorem, the average value theorem, things like that I'll teach you. But most of them say, if it's continuous, this is true. So continuity is extremely important. How will you prove continuity, okay? Continuity, let me draw some things that are discontinuous on this cute little chicken with a hat, okay? That is discontinuous. The loose definition of discontinuous, continuity, the loose definition is you can draw it without picking up your pencil, okay? There's point discontinuity, which is a hole. There's jump discontinuity. So this is one, this is another one. There's infinite discontinuity. Some of you may have seen oscillating. It's the weirdest thing. It like comes in and goes like this, but you just never stop doing that. And then it picks up on the other side of whatever is undefined. It's bizarre. It's just going like this and you can't go, it was at 4, it was at -2, it just bounces forever. You can zoom in and it's still doing this. You can zoom in and it's still doing this and you can't capture it. That's called oscillating. You don't deal with that. We deal with that a tiny bit, not a whole lot. I think those are the only ones I can think of right now.
And the infinite one.
Okay, this one? Infinite discontinuity?
Oh, sorry, I didn't see that you drew it.
And oscillating discontinuity. Okay, so let me give you the 3 things that you can always tell me. This is how the recipe for how you'll say if something's continuous. The first thing, I'll just use like our book, I think, uses this little 1, 2, 3. You can go 1, 2, 3. You don't have to put these little thingamajigs. By the time I've done that, I could have just gone 1, 2, 3, okay? It has to meet 3 criteria, all right? First of all, f of c has to be defined. Like if I ask you if this is continuous at 4, no. You're done. It's discontinuous, it's not defined at 4, so why am I going to look at it anymore, okay? So So sometimes it's game over at the first step. All right, f of c is defined. Then the limit of f of x as x approaches c has to exist. Sorry, I know it bothers you. It used to bother me when teachers would leave little spots on the board. This has to exist. Okay, so here, if I'm looking to see if this is continuous at C, is that one continuous at C? Is f of C defined? I have an f of C, don't I? Okay, but does the limit exist? So you have to take that next step. All right, then f of C has to equal the limit of f of x as x approaches C. You're going to be tempted to say these are continuous because they meet. And then you're doing a continuity worksheet, okay? In a little while. Don't say that. The way to say that is this last statement. What I mean by that is, what if this had been true? Is f of c defined?
Yes.
Does the limit of f of x as x approaches c exist?
Yes.
And are they indeed the same thing?
Yes.
That proves continuity. So I have an f of c. I have an f of c. I have a limit of f of x as x approaches c. Is that continuous? Okay, but now it is. This statement really says it all, okay? If you know it's continuous and you're sure, you could just say the third statement. Doesn't that tell me there is an f of c? There is a limit of f of x as x approaches c, and they're the same? Okay? So let's look at this real quickly. I'm sorry, that just needed a slide of its own, so I'm not even going to write on it. It's just so cute. Yeah, it's just the cutest thing. Okay, so I didn't even bother resizing that. That's super cute too. There's a flower somewhere you can't see. Okay, so if I have y equals x squared plus 1 when x is greater than 3 and this is less than or equal to 3. Or I'll show you what I'm thinking. I want to make up like a line where it will be continuous. So I'm saying to myself, 3x plus what number will equal 10? Do y'all see what I mean? 3x plus what value? Why did I say 10? Because I filled 3 in here and I got 10, and I'm trying to make them meet each other and be continuous, okay? And I want it to be continuous at what number? I want this one to pick up where that one was off, okay? So if I put in 3 here, I get 9 plus k equals 10, so k looks like it's 1. All right, so now, if I graph x squared plus 1 when it's greater than 3, here's 5, 10. It goes like this, and 3x plus 1 comes in like this, and it looks like it also ends at 10, doesn't it? Okay, so is there an f of 3? Is there a limit of f of x as x approaches 3?
Yes.
And so as f of x, I'm sorry, so then I can say at the very end, it's past the first two statements, so I can just say f of 3 equals the limit of f of x as x approaches 3. It is continuous, okay? What if you have one that does this, and it'll be the last thing I do. I have a worksheet for you to do for homework, but you're not going to have to do it all, so check assignments, which I haven't posted yet. These 15-minute days are really hard to plan for. Oh, there's the flower. Okay, so what if I have this? All right, there is an f of c. Is there a limit of f of x as x approaches c?
No.
So you could say this is discontinuous because the limit of f of x is x approaches c does not exist. Okay? If I have this, okay, you would say there is no f of c. F of c is not defined. Okay? What if you have this? Is there an f of c?
Yes.
Is there a limit of f of x as x approaches c?
Yes.
Are they the same thing?
No.
So you could just say that statement with a not equal to. F of c does not equal the limit. That way you've said there is an f of c, there is a limit, but they're not the same. Okay, please, I'm gonna actually have to give some thought as to which ones on the worksheet I want you to do. So just, do something else until I post the assignment, which will probably be in a few minutes. Alright, so pick up a worksheet on the way out. You will probably see me post them for the girls that left, or I'll just tell them to come on and pick up a worksheet. Oh, that's not,
I'm like, wait a second.
that's mine, that's not mine too. Oh gosh, where are they? Maybe they're just here. Maybe so. Yeah, we don't want to take them. See if that's front and back. Is that front and back?
Yes.
Okay, that was it. All right, make sure you have a front and back.
Sorry, I just wanted to.
Oh.
It's my like thing.
That way I know you're really at the night. Bye, girls.